Okay. Yeah, this is the first time I'm actually doing this. So why not? Why not? Why not? Why not? So let's make an attempt at dealing with these questions. Yeah.
Okay.
Yeah, this is the first time I'm actually doing. Okay, so that was a bit strange. I had to mute so that I can focus on not hearing a loop. Let me see if I can. Okay, good. So I think I have everything. Yeah. All right. Yeah. Okay. So we have 7, we have 3, and we have 6. Right. Um. Now it really depends on what you want to do here, right? Because one of the problems with these types of questions is this. You have this here. You probably want to deal with this first, and then of course include this after, right? So maybe we want to leave the 1 and 5/6 for last. So, and of course, the neat thing about 7 and 3 is that they are prime numbers. And the beauty about prime numbers is that once the numbers are prime, the LCM is pretty much multiplying 3 by 7, right? So, and then of course you have 1 and 4/7, which this would translate to 11/7 for those who probably struggle with turning these into improper fractions, right? So this would be, I would say, 7/7 multiplied by 1, and you add that to 4/7. That will give you 7/7 plus 4/7. So 1 and 4/7 is actually 11/7. So once we're comfortable with that, we're going to go over here, right? We're gonna go over here. So now you are working with 11/7 plus 2/3. And again, the LCM of 3 and 7 is 3 times 7, right? So that's just to clear up that space right there. So let's work on this. Multiply 7 by 3, 3 by 7. Multiply the denominator by 7. We'll do the same for the numerator and the same for the numerator. 3/3 times 11/7, 7/7 times 2/3. So this is going to be 33/21 plus 14. So let's say 33 and 14. So we're going to have 47 over 21. All right, so now all of that is the result of this. And then from this, we will subtract 6 over 6 plus 5 over 6, which is 11 over 6. There we go. All right, so my LCM trick will come into play. You have 6, you have 21. Let's see how we can work with this. So we're going to have what are we going to have this time around? 2 times 3, 3 times 7. So how would we work this out? What would we actually say about this? Well, what I typically do is I come up with the analogy of the house versus the room, right? So if we are looking to buy the house is 2 by 3. The room is 3. So if we buy the house, then we essentially get the room. So all that's left is to get 7 involved. And that gives us our LCM, right? So 21 times 2, 42. So our LCM of 21 and 6 will be 42, right? So what does that? Oops, sorry. I should have used my my drawing tool. So let me just use that there. There we go. That's what we should have. So this part here is 21. So we'll multiply 21 by 2, right? And then this part here is 6. So we multiply 6 by 7, right? So let's have a go at that. So we multiply the 11 by 7. That's going to be 77. And we're going to multiply 47 by 2. This is looking a lot like 94. 94 minus 77. And of course, I have another trick for that as well. So here we go. This is for those who are like me. I don't like to borrow at all. I don't. So what's easier to work with? I think it's easier to subtract 80 from, well, okay, that was not the best drawn 0. Yeah, that's a little bit off. So what do I add to 77 in order to get 80? I will have to add 3 to 77 to get 80. Then I will subtract 80 from 94, leaving me with 14. And we will add the 2. Therefore, 17 plus 77 will give us 94. So finally, our answer is going to be 17 over 42. So that should take care of things, right? So we dealt with these two that were paired together first, right? From this, we got 47 over 21. We got, was it 47? Yes, it was. I forgot what I did, right? We had 14 plus the 33. Right, yeah, this is what happens when you forget to write all of your steps, right? So that's the reason why I stopped and asked myself about that. So 33 over 21. And if we add 33 over 21 to 14 over 21, right? Yeah. This is how we got the 47 over there, right? This is why I encourage all of my students to write all the steps. When you write all of the steps, you don't leave anything out. So this is how we ended up with this here, right? So adding these two comes from this, and that gives us our 47 over 21. And this here, 1 and 5 over 6, is our 11 over 6, right? So yeah, that should take care of all of this, right? 17 over 42. That is our answer for that right there. So we just got rid of that question. Now, I am seeing something on, I don't want to say indices, but knowing indices makes a question like this one incredibly easy to do, right? It's incredibly easy. So breaking it down as a fraction in its lowest terms, the cube root of 27. So let's just call it what it is, right? What is the cube root of 27? What is it really? So just like the square root to a square, you will have a cube root to a cube. Another way to look at this is to write 27 raised to the 1 over 3, right? That is another way to view this. So you can have the cube root of 27 or 27 raised to the 1 over 3. Of course, we know that 27 is the same as 3 raised to the 3. And of course, if we follow the rules of indices, this will be the product of 3 and 1/3. And of course, if we know anything about reciprocals, once you multiply a number by its reciprocal, you're going to get just 1. 3 to the 1 is equal to 3. And the same will be true for over here, right? The cube root of 3 raised to the 3. Let's just represent it the way it should be. This cube root out here cancels that exponent, leaving us with just 3. Right? So it is clear what our numerator is going to be. Our numerator is just going to be 3. Now, 9. If we remember 9 as, if we remember 9 as 3 times 3, then if you have 9 times 9, which is exactly what 9 squared is, then what you have is 3 by 3 multiplied by 3 by 3. So 81 is the same as 3 to the 4. So you have 4 3s down here. So now it's literally right in front of us. So this will leave us with 1 over 3 times 3 times 3. 9 times 3 is 27. So you're going to have 1 over 27. So writing this down in its lowest terms is going to be 1 over 27. All right? Get rid of this right here. And where's my rectangle? There we go. So we have our answers for this one here and this one here. So we're going to move on to part B, and why not? Why not? So this one is put in words. The thickness of one sheet is given as 485 times 10 to the minus 2. Now, if we remember 10 to the minus 2, or again, this comes right back to indices, right? Because if you remember a to the minus n is the same as 1 over a to the n, right? That is something that we must remember. We must remember that a to the minus n is the same as 1 over a to the n. And of course, that means this is 1 over 10 to the 2, and 10 to the 2 is 100, right? So what you're looking at really is 485, and that's multiplied by 1 over 100. Yeah? And then one more thing, it's going to be multiplied by 75. Now, why would we need to do that? Because it says a construction worker uses 75 sheets of the cardboard stacked together to insulate a wall. So they want us to prove that by multiplying 485 by 75, dividing it by 100, it should give us 363.75 millimeters, right? So let me just get that out of the way, right? So what they're asking us to do really, they're asking us to prove that when we multiply 75 by this measure right here, that the result we get will be this. right? So let's do it and see what we come up with. So we'll have 485. We'll also have 75. Five fives, we have 25. 40 plus 2 is 42. 20 plus 4 is 24. All right. Now let's go again. We will have 35. 56 plus 3 is 59. And then 28 plus 5 is 33. All right. So let's see. Let's see if this really holds up. So we'll have a 7 here, a 5 here, a 3 here, a 1 here. 3 plus 3, that is 6. 0 plus 3. There we go. So this number will be divided by 100. Resulting in 363.75 millimeters. So we're literally proving that if we multiply this number, we could have, this is, if we want to look at it another way, what they were asking us to do is multiply 4.85 by 75. Because if you multiply 4.85 by 75, you would still multiply 485 by 75. And what you would do is, to demonstrate the act of dividing by 100, you would go 1, 2. Right? So you can decide how it is that you want to represent it. Right? You can write 485 times 1 over 100, 485 divided by 100, or you can use 4.85, right? So let me just write them so that we can see. So you can have 485 times 1 over 100, or 485 divided by 100, or you could use 4.85. So this is one option. Right? So there are the options here. For 485 times 1 over 100, which is the same as this, which is the same as this. Yeah? So 3 different ways of expressing the same number, right? This results in this, and this results in this over here. So the easy part now is, now that you have your number, you have to correct the significant figures, correct to 1 decimal place, and place it in standard form, which, okay, So in standard form, 363.75 would be 3.6375, and you multiply that by 10 to the positive 2. The question is, why would it be positive if we're going in this direction? Because if you have this and you move to the left 2 times, shouldn't we be saying that it is actually going to the left? Well, to answer that question, really, what we're trying to do is we're trying to get this number. So what change must we make to 3.6375? And by the way, what we're doing, just to be clear, we're doing this part here, standard form. What change must we make to this number here so that it becomes 363.75? You would have to multiply this number by 100. So the 100 is represented by 10 raised to the positive 2. All right, and of course, let's not forget the unit. So there's that. I feel like that would have been the trickiest part of the question to do, apart from this, where when it comes to significant figures, you don't necessarily start from the first decimal point, you start from the first non-zero digit, right? So you have 363.75. So 2 significant figures, that would be 1, 2. So unfortunately, this would be less than the 5. So what you're going to get here is what looks like 360. You even want to go as far as including decimal points. Yeah, this is less than 5, so yeah, not much more you can do with that. Right? And then correcting it to 1 decimal place is the easiest one. Right? So what we have here is our answer for part C. And what we have here is our answer for part A. Right? So of course, let me not forget, the unit is in millimeters, so let me write that there. Now the last thing, would be the easiest one, which is one decimal place. Jump once, here we go, 363.8. All right, so that's going to be our answer for part B. 1 mark each. Now, the thing that beats a lot of people when it comes to this question here, part C, right, is they don't quite remember the safest way to do what you would call a rate of conversion, right? So typically, when we're doing measurements, or even if you think about anything, right? 1 hour is 60 minutes, and 1 minute is 60 seconds. So if you ask how many seconds are there in an hour, how would you figure that out? Because you don't know how many seconds are in the hour. You don't know. What you do know is that 1 hour is 60 minutes, which really and truly translates to what? It translates to 60 times 1 minute. So if you're to do this, what do you really have in here? You have 60 times 60 seconds. That's what you really have. So you could literally replace this here with 60 seconds. This is what tells you how many seconds will be in 1 hour. So the thing that trips people up is not knowing where to start when it comes to dealing with conversions, right? Now, that's one way of looking at it. And there, as long as you know so you always have to start with one thing being equal to a certain number. So it's 1 of this is equal to X amount. And then there's the comparison between what another amount is. How many hours would that be if the amount of seconds is, say, let's say 7,200 by example? How many hours is 7,200 seconds? So technically that is the sort of thing that is happening here, except we're using currency and not time, right? That's what's really happening here. So let's look at this. 4,500 Mexican pesos, right? He receives 630 ECB, right? So let's do this. We have 4,500, right? And on this side, it's called MX. And they say that amount is equal to 630 in terms of ECB. How would we get the value of just the 1 ECB? How would we go from 630 to just $1 of this amount? No, you can actually see it just by looking at this. Let me draw that table so we can see it. Or not so much a table, but maybe. So I have a rectangle here. So 630 of these is equal to 4,500 of these. So how much is one ECD worth? What is the value of one ECD? So the answer to this question is fairly simple. If we divide, and let's just remove that for a second. If we divide 630 by 630, that will give us the value of 1. Therefore, if we're going to divide the right by 630, we must also do that to the left. So we're going to divide 4,500 Mexican pesos by the 630. And if you really think about it, what are we actually doing? We are reducing fractions. And again, the prime numbers will actually be very helpful to you in this regard, or knowing your powers of 10, right? Because now you know you have 450 over 63, right? You have 450 over 63. Now, if you know your prime numbers, what will we have upstairs? You'll have 9 times 5 times 10. So you have a 9, you'll have a 5, you'll also have a 10. Wait, give me 1 second. All right, so yes, again, so we'll have 9, which is 3 by 3, a single 5, 2 by 5. So we're going to have 2 followed by 3 by 3 followed by 5 and another 5. Right? Which makes sense. 45 is 3 by 3 by 5. So therefore, 3 by 3 by 5 times 2 times 5 will give us all of this up here. And then 63, that's going to be 9 times 7. So what we're going to have is 3 by 3 by the 7. So highest common factor is going to be 3 by 3. So if you divide 50 by 7, that's the value that you're going to get in Mexican pesos right here. So you're going to have 25 times 2, 50 divided by 7. That's your answer right here. You can use a calculator at this point, right? Or considering what I would like to do, if you have 50, you divide it by 7. Well, that's not too bad, because 7 times 7 is 49. So what you really have is 7 and 1 over 7. That's what you really have right here. So we don't even have to spend a whole great deal of time on it. I mean, even if you wanted to convert 1 over 7 as a decimal, right? Let's say you wanted to do that. All right, let's do this. And I'm going to pretend that there's a lot of zeros behind this number, which no, it's not, but yeah, forgive me for having the zeros a little bit closer than I'd like. Let me try and get rid of one of these. So let's do one more. Yeah, that should do it. And of course, we'll have a decimal point here, right? And then of course, we'll have the multiples of 7. So we'll have 14, we'll have 21, we'll have 28, we'll have 35, we'll have 42, we'll have 49, '56, and then 63. And finally, we have 70. All right, so no amount of 7 fits into 1. So that will be a 0 right here. See, this is why I have to be careful which tool I use. There you go. There's our 0 right here. Now we're going to pretend that we're moving on to 10, which it's really 1.0, but we're going to pretend it's 10. We're going to pretend that the decimal point is not there. So we're going to compare 10 with 7, and only 7 is the only multiple of 7 that is smaller than the 10. So the rest of these will not be included. And therefore, we can only use the 1. We can only use that one. 10 minus 7, that will give us 3. So we're going to take that 3 and put right here. Although that doesn't look like the 3 I want. Try and draw it a little bit, just a tad better. Just a tad better, fine. There we go. So now 30, let's try the 30 and see how that goes. So it's bigger than 7, bigger than 14, bigger than 21, bigger than 28, but smaller than 35. So we'll go from 1 to 1, 2, 3, 4. So we're going to have 4 here. So 30 minus 28, that's going to be 2. Now we're going to have a 2 placed right here. So it's going to be 20. And 20 is only bigger than 7 and 14. So, you know, once we continue, this will probably go on forever and ever, amen, right? So this is going to be, so we'll have this here, but it's not bigger than 21, 28, or 35, or the rest. So 1, 4, then 2. So let's see what we have here. 20 minus 14 is going to leave us with 6. And of course, 60 goes all the way to the 56. Right? All the way to 56, excluding 9 and 10. So 2 from the 10 leaves us with 8. So we're going to say that this is that. So, sorry for being so elaborate. We round this off, we'll get 0.143. Round that off, we'll get 0.14. So, all in all, we would have 7.14 Mexican pesos. Right? Now, again, I'm only doing this because this is how you would, this is the only way you can get the decimal without using a calculator, right? So 1 ECD is equal to $7.14 in Mexican pesos, right? So just wanted to highlight all of that. And I believe that's it. I may have another question, but seeing that these are all the questions on this paper, I'm just going to focus on this. So again, this is the first time I'm actually streaming to YouTube like this. This is honestly the first time. So I appreciate your patience, right? Definitely appreciate your patience. Once again, if you also see my videos like this on Facebook, I will make them available on Facebook as well. You know, the usual that I say to you, there's a WhatsApp button, you press the WhatsApp button, you can feel free to look at my WhatsApp statuses, you know, to stay in touch with everything that I'm doing. So again, thanks for watching, and I'll see you around. Let me say it again. Thanks for watching, and I'll see you around.